Welcome, everyone. Tonight's topic is winter constellations, a little bit of constellations in general, discussion of the winter solstice and how we're closer to the sun when it's colder in the northern hemisphere, and then my take on what the Star of Bethlehem might have been. So this is actually an updated version of a presentation I gave at the Broward County, Maine Library back in 2013 in association with the Florida 500 event, which was celebrating the beginnings of the state of Florida. So updated some things. So we want to talk about winter constellations. What are the big, bright, obvious ones? The winter solstice, what is that? What's that all about? And then the Star of Bethlehem. Opinions vary, and I'll give you a couple of what I believe. Okay, the winter constellations, the big, bright, recognizable ones. They're easily distinguished patterns. You don't have to be in a truly dark site to be able to spot them. They are Orion the Hunter, Canis Major and Minor, the hunter's dogs, Taurus the bull, the twins, Gemini, and the obvious, not specifically winter ones that you can use for navigation, like Ursa Major and Minor, the big and little bears, or the big and little dippers, and Cassiopeia, the W or M, depending upon which direction you're looking at it. So let's start with just points of light in the sky. These are just points of light, but people like to add things to it. It's like, what are we going to call that one? And is that one related to this one? And how do we remember all of these in this particular area? And that's where asterisms come into place. That's just, you pick a few dots in the sky, you give them a name, and eventually they officially become a constellation. So we start by, let's just give the stars names. So you see a lot of the stars that have names, they have all these Arabic sounding names because those were being cataloged when we were in the Dark Ages. So we picked up a lot of existing names. And then we start drawing lines between the dots and giving those names. But the initial names didn't always stick, and the initial shapes didn't always stick. And we have nowadays this thing called the International Astronomical Union, or the IAU, and they've formally internationally recognized 88 of these named asterisms and their shapes. But that didn't stop H.A. Ray from having his own shapes that were his asterisms that he thought were much easier to remember than the IAU constellation lines. But it's just, whatever people think of and officially get identified. But as soon as you put the background mythological images in place, oh, now I can see how you might take those dots and join them up and come up with whatever your constellation is. So here's Orion the Hunter.
No TV back then, and there was Ozo involved in it.
Right. It's kind of like that was their thing back in the day, is to look at spots in the sky, give them names, and that's the hunter. He was chasing after some animals, and he had dogs with him, and they went into an entire mythology of it. And he was a really aggressive guy, so he would chase after a certain collection of women, and therefore you're going to put those up in the sky too. And here's the queen over here, and yeah, just the way of naming the stuff. So that's Orion the Hunter. And then you've got his dogs, Canis Major and Canis Minor, or Canis Minor and Canis Major, which the dogs actually have names. I just forget what they were. But the brightest star in the northern hemisphere is Sirius. That's in...
The name of the dogs are Procyon and Sirius.
That's the dogs' names? Okay.
Before the dog, Procyon, and the name Canis Minor and Canis Major.
So why would you name your small dog Raccoon? Because that's Procyon. Anyway, the brightest star in the northern hemisphere is not Polaris, it's Sirius. And the other stars in the constellation Canis Major are somewhat difficult to see. I mean, Wezin and Adara are easy enough to see if you have a clear, dark sky. But otherwise, you're just going to see Sirius. And then we have Taurus the Bull, of which you'll see Aldebaran or Aldebaran. But it's harder to find Elnath. And then you have the adjoining constellation, which has Capella in it, which is not part of Taurus. And then down below it, you can see Orion. And then you have the twins, which are upside down, which have Pollux and Castor. And those are the only two stars naked eye that you can see in that constellation. And then you have the navigational ones. These are not wintertime only, they're circumpolar. So depending upon the time of evening and the day of the year, you can see them at different angles. So if you, and it's not showing me the bottom of the slide. Down where it says horizon, there's a green line down here that is the horizon. So if you measure up from the horizon to where Polaris is, that many degrees, that actually turns out to be your latitude for the northern hemisphere. For the southern hemisphere, there's a different approach to calculating it, but you can actually find your location if you find Ursa Major, the Big Dipper, and you follow the tail backwards to the cup of the Big Dipper, and you follow these last two stars, they will take you to Polaris, which will tell you where north is. And then if you measure with your hand the angle up from the horizon to where Polaris is, that will give you your latitude. Your longitude's a bit trickier, but that will tell you your latitude. Very easy. So Earth seasons, we got 4 seasons. We have the vernal or spring equinox, that's March 21st, 22nd, when day and night are equal in length. Then you have the summer solstice, June 21st, 22nd. That's the longest day of the year. When I say longest day of the year, it doesn't mean like nighttime is 5 hours longer than daytime. It means like portion of an hour. And then the autumnal or fall equinox, September 22nd, 23rd. Once again, when day and night are equal on the opposite side of the sun. And then winter solstice, when you have the shortest day of the year. And that's coming up this coming week. So these are the seasons for the northern hemisphere. If you go below the equator, they have the same season dates, durations, but the season type flips. So when it's winter here, it's summer down there. When it's summer here, it's winter down there. And spring and summer flip as well. So the Earth's orbit around the sun is not a perfect circle. It's an ellipse, slightly elongated, not as exaggerated as this is, it's slightly elongated. The northern hemisphere winter solstice is in December, which occurs close to the closest point we are to the sun, which is in January, not the farthest, which is July. So the winter solstice is actually closer to when the Earth is closest to the sun, and the summer solstice is when we're farthest from the sun. It's the angle of the light hitting the Earth and how much of it is concentrated is really the determining factor of whether it's going to be hot in the northern hemisphere in the summertime or cold in the wintertime. And the Earth is tilted on its axis, which gives us our seasons, but it also means the seasons in the north are going to be flipped to the seasons in the south. And here's an exaggerated picture of the tilt. 23.5 degrees. You can see the northern hemisphere and the equator and the southern hemisphere. So if you orbit the Earth around the sun. Obviously, the Earth is not bigger than the sun, and it's obviously not as close as this picture would show. It's just meant to illustrate what's going on here. And you can see that the sun angle, given the tilt of the Earth, is such that during the summer solstice, the northern hemisphere is more directly facing towards the sun. Therefore, more of the light hits the land mass, and that's why it's warm in the northern hemisphere during the summer solstice. And then when you go for winter, it's tilted the other direction, and therefore more of the light hits the southern hemisphere. And then when you have the equinoxes, it's equal both sides. And if you want to see how all this affects how you see things in the sky, if you note the altitude and azimuth of the sun at the same time of the day, each day, over the course of a year, it will take this shape. This is called an analemma. And it's due to the Earth's orbit around the sun and the tilt of the axis causes this sort of squished, elongated, lower, bigger than upper figure eight. Okay, the Star of Bethlehem. Have to ask questions, have to dig for the, what information can you find? Well, obviously, city of Bethlehem, where is that? Province of Galilee. Okay, where is that? It is what is now referred to as the nation of Israel. People traveled more slowly back then. They either walked or on camels, and that means that they're not going to go as fast. So whatever they saw in the sky had to last, a couple of days at least. It wasn't like gone in one day, because then they would have lost their directional indicator. I'm thinking it was a planetary conjunction. The conjunction was such that the planets were not directly contacting each other at our angle in the sky. I'll explain a conjunction in a moment, but that's called an appulse. Likely Jupiter. Some say it might have been Jupiter and Saturn, but I don't think that would have given you enough brightness. Some actually say it was a triple planet conjunction, but the probability of that is much lower. More likely it was Jupiter and Saturn, which both are very bright, and when you get them very close to each other in the sky, it's even brighter. So you needed something extremely bright. So I ran the simulations and found out, yes, there was a Jupiter and Venus conjunction in what we would now think of as June 17th of the year 2 BC. Not 0 and not a winter month. But okay, well, maybe it was a nova or a supernova. The problem with that is that would be extremely bright, maybe visible in the daytime, but only really that bright for a day or two. If it was a nova or supernova in our galaxy and it was daylight visible, we would still see a remnant of it in the sky today, but we don't. If it was in another galaxy, it wouldn't have been as bright. Supernovas happen all the time in other galaxies, and you have to have an astronomer at night with the camera to see that one star in that distant galaxy getting brighter for a day. So when did it occur? For the brightest effect of a conjunction, it looks more like summer, not winter. And you have to remember what calendar was the contemporary calendar at the time. Certainly not Gregorian, because that was modified. Maybe Julian, maybe Jewish calendar, which is a lunar-based calendar. And this was a couple of years BC, not AD. So exactly what year and what was the month? You've got to map it onto today's calendar versus what they had back then. Where was it in the sky? Well, the particular conjunction of Jupiter and Venus would have been near the western horizon at sunset. So if you want something to be used as a beacon for several days, and you could follow it over the course of a couple of days at the horizon or near the horizon, then you had to be going east to west, not west to east. So where were the wise men coming from? Well, if they wanted to use this as a marker, this was going to be in the west, so they came from the east to go to the west. That would mean they'd come from east of Bethlehem. So if it was acting as a directional beacon, the brightness of Jupiter plus Venus could be seen before sunset for a couple of days. So if all the circumstances line up and everything is true, then it was likely a planetary conjunction of Jupiter and Venus in the summer of 2 BC, not the winter and not at like 0 AD.
I have a question.
Yes.
Okay. I want to make a statement first.
Okay.
As my understanding is that our planets and stars are moving further apart from each other. Now, I know this didn't happen that long ago, so maybe it didn't make any difference, but could it have made a difference? I mean, like, I know at some point the moon was closer to Earth and looked bigger at that time than it does now.
Now, as far as the Earth-Moon distance, we're talking much, much longer periods of time, tens of thousands of years for very small differences. And if it was a conjunction of planets, then yeah, there's not much of a difference there over a few thousand years.
Okay, thank you.
Okay. It's good to ask questions. So celestial alignments, what are all these, conjunction and opposition and occultations and transits? And I went looking for consistent definitions. And if you look at the astrology camp, you'll get one definition. If you look at the astronomy camp, you'll get another definition. And then if you just look at if we expand it out and say, instead of us focusing just on Earth, what if we just said 3 celestial objects? What is the relationship between them? And you can find terms for conjunction, opposition, occultation, and transit that don't say, yeah. No, syzygy is a different one. There is another
Three bodies aligned. This is syzygy.
Yeah, there's another one called syzygy that they'd like to say is related to the sun, but it need not be. It's just 3 things in an alignment. So anyway, a conjunction is you're standing somewhere, you're an observer, you look up in the sky and you see 2 things close to one another. That's a conjunction. Nothing big serious about that. If you look off to one direction, you see one object, and you look off to the other direction, you see the other object. That's essentially an opposition. They're opposing one another. An occultation is you've got something near to you like the moon, and you've got something farther away like a planet. And because of orbits, the planet disappears behind the moon, or the moon goes in front of the planet. That's an occultation. It doesn't have to be complete. You can have partial or grazing occultations. And then you have transits. A transit is when you have a smaller object in front of a bigger object. It doesn't completely occult it. It just sort of goes by it. And this is very popular for a planet like Jupiter, where you have lots of moons, and the moons will go in front of the planet between your perspective and the planet, and you happen to have the sun behind you, and therefore the little moon will cast a big dark circle on the cloud layer of the planet Jupiter. So that's a transit. But
Question regarding opposition.
Yeah.
There's degrees of opposition. They don't have to be directly straight across from each other. Or I'm asking the question, is there a degree?
They'll stretch the definition. Astrometrically speaking, they should be 180 degrees in opposition to one another for it to be in opposition. But in general, people will just say, if it's in general on that side of the sky, and the other one's in general on that side of the sky, that's kind of an opposition. And if it's, like 5 degrees off either direction, they won't worry about it. They'll just declare it to be in opposition.
If it's 180 degrees, you wouldn't be able to see the other one, would you?
Sure, why not? Remember, the ecliptic is tilted.
Okay.
Yeah.
Okay, thank you.
Sometimes they will say things like, the Earth will be on one side the sun will be in the middle and the other planet will be on the far side. But if you think about that as an opposition, that means that the sun is going to occult the distant planet. So if it's that kind of opposition, you wouldn't see the other planet. It'd be on the other side of the sun. So that's why I have to use more general definitions for these. So if we think it happened to be a conjunction of Venus and Jupiter, where were they in the sky at the time? And I ran the simulation software, which knows how to accommodate for the older calendars. And I said, start showing me some stuff. And I literally just ran it forward and backward until I found this really bright thing in the sky, which was Jupiter and Venus in conjunction. They were not right on top of one another. You know, they weren't obscuring one another. So it was literally the sum. They were close enough that it was the sum of their magnitudes. And Venus at that time would have been a magnitude minus 4.3, which is easily visible if you know where to look in the daytime. And then you add to that Jupiter right next to it is magnitude minus 1.7. Between the two of them, 2 hours before sunset, you could easily see that in the sky. And because of the Earth's atmosphere and the scintillation, they would be fighting for brightness dominance and be different colors, kind of like Canopus is these days, but even brighter. So that's why I think it was a conjunction of Jupiter and Venus, because that was a naturally occurring item, very, very bright. And it lasted in that part of the sky for several days before they were far enough apart to separate again.
But now, how do you reconcile the difference of the dates, 2 years BC?
I don't. I let other people figure that out. How do you reconcile with it's June versus December? I don't. I let other people figure that out. And if you look at the history of why is Christmas in December, it wasn't always in December. It was earlier in the year, and then they fixated on a shopping season, a commercial endeavor, and that's why you have Christmas.
Before that, with the Roman Empire, they used all those important dates. They match with the local pagan tradition. So
yep.
The Christmas is to match the winter solstice and Saturnalia, and you have to think that when you count people, what is the name of the
census?
Yeah, the census that they have during the time of the birth, it was kind of matching with what Monroe found out. They just fixated later those dates.
I also looked at who was the leader of what country at what time, and you could actually go back and say, okay, if he was born, who was the King Herod at the time? And you trace all that lineage, and what you find out is, yeah, it wasn't actually 0 AD. It was 1 BC. Not 2 BC, but 1 BC. So, you know, when somebody says, this is the answer and it's the only possible answer, it's like, study the information, you know. You can believe whatever you want to believe, but I actually did the simulations in Starry Night Pro, which knows how to deal with calendars going many, many thousands of years back. So it knows how to go over the little adjustments for Gregorian to Julian to lunar calendars and things like that.
I have a question.
Yes.
From what I understand about planets and the sky, that we have repeat periods of time. So like Venus and Jupiter, how often do they have this planetary conjunction? Do we get to see it in the sky?
Well, not this evening, but I do think that I have seen conjunctions of Venus and Jupiter in my lifetime. I'd have to go back and look at them. But, you know, think of it this way. How often does Venus go around the sun? Well, faster than the Earth goes around the sun because it's closer. How often does Jupiter go around the sun? Well, it's going to be several years because it's farther out. So if you line that up, you'll find an oscillation period of Venus going around faster, Jupiter going around slower. And at some point, we'll be in the mix and be able to look out in the sky and see Venus and Jupiter in the same part of the sky at the same time. And that will occur some multiple of Venus orbits.
So we may have it happen again, maybe
Yes.
in our lifetime.
Yes. It probably
And
already
then will
has
it be
happened in
bright?
your lifetime, but nobody took notice of it.
But because we have TV. Because
No,
we're distracted.
No, because if it took place 20 years ago, maybe you weren't as interested in astronomy.
Well, 20 I would have been, but 40 maybe not. But still, but then it would have been something that would have been of interest if you could see it in the sky.
Yes, and I've looked at certain conjunctions, and in order for the media to hype them, they'll label something as a conjunction if it's 5 degrees apart. Like, yeah, it's a conjunction, but how about a half a degree conjunction when they're really close together? That would be even better.
Right.
If it's 5 degrees apart, you can't see both the objects in your telescope at the same time. But if it's a half a degree apart, you can get an average telescope to see both objects in the eyepiece at the same time.
So you're saying that the news could have put it out there. I just wasn't aware of it at that time.
Right. Or didn't you remember seeing that time when Mars was as big as the full moon?
Oh, yeah, my internet.
Yeah. So we discussed the winter constellations, the prominent and obvious ones, Orion, Taurus, Canis Major, and Gemini. And we discussed the constellations that are useful for navigation, the Dippers and Polaris, what the winter solstice was. That's the season of this time of year for the Northern Hemisphere. It's the shortest day of the year for us, start of winter. It's when the Earth is close to being nearest to the sun, not farthest. And then, in my humble opinion, from what I've read, as far as planetary motions go, what my take on the Star of Bethlehem is, it's a planetary conjunction between Venus and Jupiter that occurred in the summer of 2 BC, summer, not winter. And then I included information about me for those people that care, if they're watching the video on YouTube. And then some more information if they want to go look up things about asterisms and constellations from the International Astronomical Union. You can find out all the 88 constellations and their names. The Earth, Moon, Sun system, which starts talking about conjunctions and oppositions and such. The Analemma, which is, I just find it fascinating that people actually record the Analemma and go, look, it's a sloppy figure 8. It always has been. And then celestial alignments, like oppositions and conjunctions, when you start looking at it from beyond just our humans on Earth point of view, and you start thinking about, okay, if I happen to be living on Mars, would I still see conjunctions and oppositions and occultations? Yes. They're just 3-body problems.
Now, you said this was your opinion, but
Yes.
you must have, in your research, come across of other people's opinions. And I
yeah.
think up until tonight, I gather I've heard a lot of times that, from just what I heard, not read, I haven't researched it, but I heard about it being an exploding star, like a new star was born.
No, I included that in the explanation, which was a supernova or a nova.
Right.
Not a star turning on, but a star ending its life. And
Oh.
those are very bright, but they're very short-lived. They peak on the order of a day or two at most.
I see what you're saying.
If it's a supernova, unless it's really, really close by, they're never going to be bright enough for you to pick them out in the late afternoon.
Okay.
There's going to be something where you have to be in a dark sky, and an astronomer would catch that in his camera image, but you wouldn't catch it naked eye. But a planetary conjunction where you're summing 2 of the brightest objects in the sky, yeah, that you could see in the late afternoon.
Okay. I must have missed that, or it didn't register. That's what I was thinking of.
And
Thank
you
you.
can see the remnants of supernovae, and you can kind of figure out when they went off and which records of the historical date they actually done.
For example, one of the earliest supernova that we actually, not me, but astronomers actually researched, is the Crab Nebula. That's why in the Messier catalog it's M1. The Crab Nebula is a supernova remnant. Now, when did it occur? Ancient Japanese records show that it occurred several thousand years ago. So yeah, it was bright enough supposedly to see in the daytime. But for how long? Maybe a day or two? But
No, they last longer. They last, like, if it's supernova, they can last like more than a week.
What do you mean by last? Bright enough to see in the daytime, or bright enough
No,
for
when
the astronomer to
when
get
the
a picture of it?
supernova brightness lasts more than a week. The gas stars, they last long.
Okay.
Now the novas, they go away faster.
Okay, but bright enough to be seen in the daytime?
Only if it's too close.
Yeah, yeah. And that would have left a remnant. If it was bright enough to be seen in the daytime, you would have seen a remnant. But if you're talking about how bright are they, if you're an astronomer taking, deep sky pictures of it, yeah, they could last for a week. But you wouldn't see that if you didn't have a telescope with a, light sensitive camera. So let's think back to the Star of Bethlehem time period.
Now I'm reading here. Over the span of 2,000 years, the Chinese astronomers recorded a total of 20 such as candidates, including later explosions noted by Islamic, European, and possibly Indian other observers. And then some of the petroglyphs in Arizona or New Mexico, they look like a supernova too. They speculate that could be one of those. The Pueblo also mentioned that there's petroglyph for the Pueblo people.
Well, there's a simple way to deal with this, which is you take your software that simulates the night sky and you run it backwards through from like 2 AD to 2 BC, and then you point it in that part of the sky and see what you see. And if you don't see any stars that became supernova remnants, wasn't a supernova. But if you see a conjunction, that would be bright enough.
And on Wikipedia, I found here the present day New Mexico as four-pointed star-shaped petroglyphs. This explosion appears in the constellation of Taurus, where it was produced by the Crab Nebula remnant and at its peak. And its luminosity of SN 1054 may have found 4 times as bright as Venus, and it will remain visible in daylight for 23 days and was visible in the night sky for 636 days.
Okay. But where was that in the sky from the years 2 BCE to 2 AD? It wasn't there.
No, yeah.
Right.
So yeah,
So couldn't have been that
there was no
supernova.
Nova register.
That's
And
what I
back
said.
then they did. They actually register a lot of things. Yeah, you
Right.
could have
So
tried it.
that's why I said you go for the date range. You don't pick a particular individual day. You go for a range of years, and then you look in the western part of the sky, and you see what bright things are there that lasted for several days. And what you find out is Jupiter and Venus conjunction.
So the Tycho Brahe nova was in the constellation of Cassiopeia was verified, in the 60s.
What year did it occur?
1572.
Obviously not in this time frame. No, she's trying to point out that there are other bright celestial events, which are supernova, that do last for a period of time. The issue is that none of them occurred in the date
No,
range
no.
that I'm talking about.
There is no record in the
Right.
beginning.
There's no
of
record of a
the-
supernova in that 4-year time span.
Could it not have been recorded though?
If they were already recording them in Japan that long ago, then I'd say if one did occur, they would have somebody record it. And they would have
Yeah,
said where it was in the sky. And you have no indication of where this star was in the sky in reference to other constellations. Because at that time, what were the constellations? They were different mythologicals. There were different myths that formed the shapes. For example, what we think of as Ursa Major, if you go over to China, that's the constellation of the 5 judges. If you go to India, it's an elephant. So I just look at it as, give me a date range, give me a direction to look, give me the location on the planet, where they were, show me something bright. And what I found bright was a conjunction of Venus and Jupiter that lasted for several days. Okay.
Any more comments?
Questions, comments, posers, curiosities, inquiring minds want to know?
This is the week we have the Apollo 17 50th anniversary.
Yes.
The Apollo program coming to an end.
Yeah. Not a happy time for some people that I knew that wound up doing late night shifts at 7-Eleven.
Oh, wow.
Because basically NASA just cut them loose.
Oh,
Yeah.
yeah.
I have a
What did you
little.
used to do?
Oh, sorry.
Well, I was an astrophysicist, or I was a structural engineer for the space program. Yeah.
I had an
This is
auto
my-
mechanic who told me he worked on the lunar module.
Yeah.
Wow. I throw in a little quickie from personal history.
Go
Okay.
ahead.
Okay, first of all, sorry I missed you all. Maybe I'll have one of those one day and call come to me. Glad it was a success. I knew it would be. I was always fascinated, even very young, about the constellations. And when I was in the 6th grade, clearly remember that we had an assignment, and the teacher gave each of us specific constellations, and we had to write, and it became a little book. We put it together. How did they wind up in the sky, in other words? And I think I had one of the ones you mentioned, the house. That's not Cassiopeia, with the house. And I think I had one of the
Cepheus.
dogs. Yeah, so long ago. Obviously, really long ago. But it was fun. I don't know what my story was, and I do write, but I can't remember what I wrote as my version of why they wound up in the sky, quote unquote, wound up in the sky. I also remember, across the street from where I lived, there was a playground, and I distinctly remember going and laying down on a bench, just to look up at the sky, at night, not crazy late or anything. I was young. But very fascinating, very enjoyable conversation. And this last part about Christmas and all, I had heard long ago that it really did not begin to be or actually happen in December because of what Helen said, the pagan holidays and such. But the conjunction, all of that, very, very fascinating. It's always fascinating, all great. And I wish you all again a happy holiday, which I guess we won't have a meeting next week. That'll be Christmas Eve, right?
Well, I leave it up to individuals to celebrate whatever holidays they wish to. I'm not saying somebody should or shouldn't celebrate any particular thing. So I just leave it as enjoy your holidays. For those people that don't worship certain holidays, then I just say, if you work for a company, enjoy your vacation time off this time of year, because it's a use it or lose it type of scenario, usually at the end of the year. So if you've got 2 weeks that the company owes you, take your 2 weeks at the end of the year, because they're likely going to shut down production systems anyway, because there's just not enough people there to work them. But as to which holidays you want to celebrate, I've been in people's homes and celebrated many holidays, different types
Me
of
too.
holidays. So,
Also, happy Hanukkah. Anybody that's tomorrow night again.
yeah,
Comes very close. Yeah. And having a Merry Christmas and all the others.
varies
Good luck.
from year. The alignment, there's an alignment for you that varies from year to year because one's a lunar calendar, the other is Gregorian.
Mm-hmm.
Yeah, I thought it was Monday.
But that's tomorrow night.
When I have friends that invite me over, I always have to look it up and say, when does it start this year?
Mm-hmm. I have to do that too. Not that I have a menorah right now, but I'll pretend that I do.
Yeah.
It's a nice holiday, you know.
But you light it up on Monday, right?
I think so, yeah.
Okay, I'm going to stop recording.